we're going to talk about how to find the length of diagonal line segments here by using the area of a square that's built off that line segment. So looking at this segment below, this square is built using that same side. So if you look at this, there's a pattern here on the triangle of a 1 by 2 around the edges here, where this triangle is 1 and 2 on either side. So if you just follow that 1 and 2, 1 more this way, 2 more that way, to build the next triangle, 1, 2, 1, 2, that would be the next corner. And then do it again, 1 and 2, you'll find the next corner. And then you could do it one more time, even though you don't really need to. And there's the last 1 by 2 triangle. And the inside part here is the square we're looking for. To find that area, we just take the whole outside area, the whole outside square, and we subtract these corner triangles. Each triangle is a 1 by 2. So the area would be 1 times 2 divided by 2, which is 1 for each of these triangles. The outside square is a 3 by 3, which is an area of 3 times 3, which is 9. Minus those 4 triangles makes the area 5. If the square's area is 5, then we learned before that the side length is just what we call the square root of 5. So this diagonal length is just the square root of 5. So we're going to do a lot of examples like that. We're going to draw in your own line segment and then a square to figure out how big that diagonal line segment is. So down below and on the next couple pages, you'll see a lot of these little grids where we can draw in line segments. We want to draw in different ones each time, not just the same one. So to look for these, I always look for like what makes the edge here with the triangle. So the first one was a 1 by 2 triangle. So let's just draw a different one to start the next one. Meaning we don't want to use 1 by 2 again. So if I start somewhere like maybe right here, I could do 1 and 3 because I know that would be different. So then these 2 points I could use, and maybe not, I don't really need those in between. So this would be a new side length that we're finding because again it's a 1 by 3 and we just did 1 by 2 for the triangle. I know that can be a little bit tricky to understand. So we want to make sure you're doing different ones every time and not just drawing the same one. So we're going to use the triangle on the corner to help make sure it's actually different. So the key is the one rule is we're going to keep this line segment in this square, okay? So don't draw any line segments that are bigger than the square because then the square that goes with it may not fit on the page. But if you draw the line segment inside this box, then the square that goes with it should also fit on the paper. Maybe not in the box, but it'll fit on the paper. So let's walk through this one. So 1 and 3, so I'm going to do 1 and 3 to go down to the next corner down here. And then do it again, 1 and 3 to the next corner over here. And then that actually is all we need. We could show the last one there though. And then there's your completed square on the inside here. And every triangle on the corners is a 1 by 3 triangle. So 1 times 3 divided by 2 would be 1.5 for each triangle for the area. Again, base times height divided by 2. The outer square is a 1, 2, 3, 4 by 4. Count the spaces here. So that would be 4 times 4 is 16. Minus all those 1.5s put together would be 6, which means that the area is 10. And if the area is 10, then the side length is the square root of 10. And that's all we're really doing is just, again, drawing new side lengths in every time and drawing a square that fits with it, and then using the square's area to then find the side length. One other one really quick, just to show you another example here, would be we did 1 by 3, we already had 1 by 2. How about a really easy one? 1 by 1. So 1 by 1 would look like this, tiny little diagonal side length like this, where the triangle is a 1 by 1 on the corners. And then just follow that pattern around, 1 and 1, to find the next corners. And then if you just keep going, it completes the square. Each of those corners is 0.5. 1 times 1 divided by 2 is 0.5, or half. And then the whole outside is a 2 by 2 square, so an area of 4 for 2 times 2, minus all those 0.5s, add up to 2, so what's left inside is also 2. If the area is 2, that means that the side length is the square root of 2. So what you're going to do is there's a lot more space in the next couple of pages. You're going to draw in new ones. Okay, draw in any diagonal length that fits in the box, and then build a square off of it. Find that square's area, and then the square root of that area represents the length of that segment. For example, if you're having trouble getting started, I'll just start one with you. We did back here, we had 1 by 2 on the triangle edge here. We had 1 by 3, and we had 1 by 1. So another combination of numbers we don't have yet could be 1 by 4. So starting here and then going up 1, right 4 like that. That would be one you can build a square out of. So if you need help starting, you can try that. Or you can also do 2 by 2. So here to there would also be a new square that we haven't seen yet. A new side length as well. So draw in as many as you can and find the area of that square, and then use the square root of that area to represent the side length.